You're in a room with 22 other people. What are the chances that there is one shared birthday? It's probably not what you think. So at first you might think 23 people in a room, well, there's 365 days in a year. We can just use a simple formula like 23 over 365, which would be about 6%. But that only makes sense if we're talking about you just matching with somebody. We don't just care about you, we care about anybody matching with anybody. So the math becomes actually way richer. So that begs the question, how many possible combinations can we make out of a classroom of 23 people? Well, if we plug in 23 as n into our combination formula, we get 253 combinations. And with 253 pairs, with each pair having a 1 out of 365 chance of matching, we can think of it as having 253 shots at matching at a 1 out of 365 probability. Therefore, we have 253 combinations having a 364 out of 365 shot of not matching. So we can calculate the probability of all those pairs not matching, and then we can subtract that probability from 100%. As is common with probability principles, when you want to calculate the probability of at least one thing happening. Plug that into this formula, which calculates 1 minus the probability of 253 pairs avoiding a match. We get about 50%. Oh, and that's assuming that every day out of the year just has an equal chance of somebody having a birthday. But the reality is that there are birthday clumps, periods where birthdays are even more likely. For example, September is for some reason overly representative. Perhaps New Year's Eve fireworks?